All right, we're asked to graph a function. They did not give us a domain, so we're gonna use a reasonable domain for the graph. What we've been doing is just that -2, -1, 0, 1, and 2. So when we do our table of values, y is equal to the absolute value of x minus 1. We're going to evaluate all of our input values, which is our x's. We're just going to choose -2, -1, 0, 1, and 2, and then see what we get for our output values, our y's. Again, the x's, this is your domain. We're figuring out what our range is. All right, so we're doing the absolute value. Oops, that is a highlighter. There we go. The absolute value of -2 minus 1. -2 minus 1 is the absolute value of -3. And the absolute value of -3 is a +3. Next one, absolute value of -1 minus 1. -1 minus 1 is -2. And the absolute value of -2 is +2. Absolute value of 0 minus 1 is the absolute value of -1, which is +1. So if you notice, when we do absolute value, you want to do all the math on the inside first, get it down to one number, and then take the absolute value. So the absolute value of 1 minus 1, which is 0, and absolute value of 0 is just 0. And then the absolute value of 2 minus 1 is just 1, so we get absolute value of 1. Okay, so now we're going to put these points on a graph. Remember, we're just forming ordered pairs, so -2 is paired with 3, so -2, 3 is right there. -1, 2, 0, 1, 1, 0, and 2, 1. All right, so now because they told us that, well, they didn't tell us, but they didn't give us a specific domain, so we are going to connect these points. I can see that these are all coming this way like this, but then I can see that it's heading this way. Now if that seemed a little bit weird to me, what we could do is just plug in some more input values, get some more x's to see, you know, is this truly going to be a V-shaped graph? What's nice about function families is you do get familiar with what they should look like. Absolute value graphs do take on a V shape like this, so I know that we did a good job with that.